Welcome to the Explainer. Our whole world basically runs on batteries, but they all have one thing in common. Eventually, they die. So what if we could predict exactly when that's going to happen? Well, today we're diving into a huge breakthrough that does just that, all by teaching an AI the laws of physics. To give you some perspective, the market for lithium-ion batteries is set to explode to nearly $92 billion by 2025. I mean, think about it. They're in our phones, our laptops, and more, our cars. They're literally the engine of the modern world. But here's the catch. For all their power, they've got this one critical weakness. Their performance just degrades over time. And trying to predict their health before a catastrophic failure, well, that's one of the single biggest challenges in energy storage today. Okay, so let's get right into it. The real challenge is predicting something called a battery's state of health, or SOH for short. That's the magic number. It tells us exactly how much life a battery has left compared to the day it was brand new. And the reason this is so darn tricky is that battery aging is this super complex chemical mess. I mean, the way you use your phone is totally different from how I use mine, right? And you can't just drain your electric car's battery to zero every single night just to check on its health. Then you've thrown all the different battery chemistries, and what you've got is a seriously chaotic, really difficult problem to solve. So to try and cut through all this chaos, scientists have traditionally gone down two very different paths. One path is built on the hard laws of chemistry and physics, and the other is built on just pure raw data. Okay, so on one side you have these physics-based models. Think of these like a master mechanic who knows every single nut and bolts of an engine. They're incredibly detailed, super reliable, but they're also kind of slow, and you have to rebuild them from scratch for every new car model. Then, on the other side, you've got the data-driven models. These are like a data scientist who's crunched the numbers from a million different cars. They're amazing at spotting patterns and can make really accurate predictions, but they don't know the why. So sometimes they can make these wild, unstable guesses that just completely defy the laws of physics. So here's the million-dollar question. What if you could combine the deep, fundamental knowledge of that mechanic with the insane pattern-finding power of the data scientist? Well, that is exactly what a team of researchers set out to do. And what they developed is this hybrid hero called a physics-informed neural network, or PIN. Now, this isn't just your standard AI. You can think of it as an AI that's basically been sent to physics class. Its entire learning process is guided and even limited by the actual physical equations that govern how a battery degrades. The method is actually pretty brilliant in its simplicity. You start with a normal neural network, but instead of just throwing raw data at it, you also tell it, hey, listen, whatever you predict, it has to obey these fundamental laws of physics. No exceptions. And the result? You get an AI that learns way faster, makes much more stable and reliable predictions, and, this is the big one, it gets it right with far less training data. But building a smarter AI is really only half the battle. These researchers also figured out the perfect data to feed it. And the key wasn't to use more data, it was about using the right data. They realized that looking at how a battery discharges is just a total nightmare. It's completely dependent on the user. One day you're watching hours of video, the next you're just sending a few texts. The data is just all over the place, it's a mess. But the charging process? That's a whole different story, especially the very, very end of the charge. As the source material puts it, that process is more fixed and regular. It doesn't matter what you did all day. The way your battery tops itself off from, say, 95 to 100% is remarkably consistent every single time. So, that's the big insight. They trained their AI to ignore all the chaotic noise from the day and to focus only on a very short, very clean window of data from the final moments of the charging cycle. It turns out this tiny little slice of data contains this incredibly rich, reliable information about the battery's true internal health. So, the theory sounds great, right? But how well does this new approach actually work in the real world? Well, the researchers didn't just test it on a handful of batteries. They went big to really prove their point. They validated their model on this massive and diverse data set of 387 different batteries. And we're talking various common chemistries, stuff like nickel, cobalt, manganese, and lithium iron phosphate from 4 completely different manufacturers. This thing was a real stress test. And the results, they are just striking. So in one test, they trained the models on data from just a single battery. The PIN model had a dramatically lower error rate compared to other common AI approaches. Basically, it learned more from way, way less. And even when they gave the other models more data to learn from, in this case from 4 different batteries, the PIN was still significantly more accurate. That physics-based head start it has just gives it this incredible, durable advantage. But honestly, this next part might be the most impressive thing of all, its ability to do something called transfer learning. They trained the PIN on one set of batteries and then showed it just a single example from a completely different set. And as you can see from the table, with just a tiny bit of fine-tuning, the AI could accurately predict the health of a totally new battery type. It can generalize its knowledge, which is, and I'm not exaggerating here, a massive leap forward for battery development. Okay, so why does any of this matter to you and me? This isn't just some clever lab experiment. This kind of breakthrough has really profound implications for how we interact with our technology every single day. What this means is an electric car that gives you a truly reliable range estimate, so you can finally kiss that range anxiety goodbye. It means a smartphone that can actively manage its own charging to make the battery last for years, not just months. For our energy grid, it means safer, more efficient storage for wind and solar power. And maybe most importantly, this could dramatically speed up the invention of new battery technologies, all because we can now predict their long-term health in a fraction of the time. And that brings us to our final question. This whole approach, fusing the pattern-finding power of AI with the fundamental rules of the universe, has proven to be incredibly effective for batteries. So it really makes you wonder, what's next? From climate modeling to material science, what other grand challenges could we finally solve just by giving our AI a proper education in physics?